Hello, everyone. Thanks for joining us today for this session on Corticon.js. As an introduction, I'm a software architect and developer on the Corticon engineering team. I write and tweet about decision services technologies at the following URL and Twitter handle. I added the session description for reference and also as an agenda. So the item in bold here summarize pretty much the agenda. We will talk about Corticon no-code, low-code capabilities. You will see why customers report up to 90% productivity improvements in developing business logic with Corticon. We will talk about deployments to front-end, mobile, and browser technologies, as well as to cloud environments. As Corticon is a cloud-native and cloud-agnostic product. We will use example applications to illustrate deployments to the most popular cloud platforms. And you will see how you can gain even more value and agility by integrating these decision services with other cloud services. Okay, let's get started. To understand Corticon.js no-code, low-code value, we'll start with a simple and yet very illustrative example. We'll start with a new modern insurance company that provides pay for what you drive insurance for your car. So our task is to create the business logic implementing the rules for this daily insurance cost. So the first thing we're going to do is switch to Corticon.js Studio and create a new project. First example. And we're going to get started by creating the vocabulary. We're going to work on all that we want the business analyst to work on. So let's create this role vocabulary. Of course, it's empty. So one of the key value here is that we can populate the vocabulary directly from some JSON data. So let's take a look first at the JSON data. For this simple example, we have a JSON data that contains an array of driver data. So for example, the first driver on that date has an insurance cost that is not yet computed, obviously, but we know it has 2 years of driving, has driven in a high-risk area, and its vehicle cost is such, and its age is 20, but it has only driven only 1 unit today. Here we have more examples. So let's see what Corticon can do directly with this JSON file. As you can see, very fast, it determined that at the root of a JSON document was an array, so a cardinality of 1 to n elements called drivers. And these drivers, if we explore the entity drivers, contain all the attributes that were in the JSON file. Of note, I mean, if we look, like, for example, age was detected as an integer automatically, and date as a date time, vehicle cost as a decimal, etc. So all in all, we can create our vocabulary very quickly. So let me save this. Of course, here you can augment vocabulary by adding, more attributes or refactoring. For example, if you don't like kilometer driven, we can refactor this to distance driven. Okay, so let me save this. Okay, so now we have our vocabulary. The next thing we're going to do is start creating rules on this incoming data described by this vocabulary. So let's create a rule sheet. Let's call it Again. And now what you see here is a spreadsheet-like interface. Essentially, here you can express conditions you want to test and what actions you want to do. So let's get started. Let's take our drivers. The first thing we're going to do, we're going to drag the age condition here, and we're going to test a range. So we're going to say 18 to 25, and we're going to say if a distance driven is, say, 1 to 29 this day, or none, actually, let's put 0. And what are we going to do? Well, we're going to charge for the insurance today. So again, I'm dragging out of the vocabulary, but now in the action, I'm going to say, hey, I want to charge $4.59. And now, if it is a driver that is, say, still 18 to 25, but has driven more than 30 units, no matter what, 30 or more, we're gonna charge $6 a day. Okay, now let me save this and show you how we test this. So the next thing we're gonna do in the project is to create a test, rule test. First example. And here, what we see is we have the 3 panes panel. In the input, we can drag a driver, and we're gonna try. So let's enter someone who is 20, has driven today 14 unit, and 15,000 big. No, sorry. Cool. Cost 15,000 and has 2 years of driving. So let's give it a try. So now we execute the rules, and we see we have a 459. So if we go back to our first example, we see we fell into this case. So let's quickly test another case. And let's say now we've driven 60. Let's run. And now we see we are being charged $6. So that's how you would quickly test your rules. Obviously, the rules are incomplete here. I only coded a simple example for us to get started. We want to put more age and more conditions, including the years of driving, right? But to get a feel for what is going on, this is sufficient. So we'll look into a more complex example in a short moment. But the next thing we want to look here is the fact that we can take here we can select this, copy it, and paste it here in the expected. So now I can set my unit test in a sense for this rule test, and when I run it, everything is clean. But let's say if someone comes along and makes a change and incorrectly change something without adjusting the testing, so say $5 here, if I now run this, we're gonna see a difference, and the studio highlights that difference. So if you care about that, you can, adjust it, or you can mark as one attribute, but you don't even want to validate when you test because you change the price very often. So a lot of flexibility here. But the key point here is that a business analyst writes rules and can test them all without programming, right? So the next thing we're going to do is going to try and deploy this on a browser. Okay, so to do that, I'm first going to create a role flow. We'll talk about role flow later on, but that's the unit. The role flow is the unit of decision service you deploy. So we're going to drag our first example role sheet here, and that's essentially the only role sheet we have. But we could imagine a set of role sheets and connecting, but we'll see that in the next example. Okay, now that I have a role sheet, I can role flow, I can package rules for deployment. And I'm gonna package my first example as a browser target. Okay, I have deploy. Okay, I come to the directory where I have deployed the browser target, and let's open it up. And this sample provides a simple mechanism where you can paste a payload here and try your decision service. So we're going to take our original input payload here, and we're going to paste it here. And let's see, the insurance is 0, and let's run it. And we can see for the first driver, we have 459. The age is 20, has 1 unit of kilometer driven. So let me change it to 60 and run again. And now we can see we have 459 here. And for someone who has 60 unit driven, we have an insurance cost computed of 5 units. So the key thing here you see is that even though we refactor our entity vocabulary attribute kilometer driven today to distance driven, you can still use the kilometer driven. So this was essentially a feature to simplify the life of the role modeler, essentially here working with distance driven today, but internally we maintain good data to know that, hey, this is mapping to the JSON called kilometer driven today. The other aspect that you can see here is that even though in my role sheet I didn't program a loop to say, hey, take all the input drivers and loop through them, the Corticon was smart enough to say, hey, there are 3 drivers data set here. I mean, there is a data set of 3 drivers. Let's apply the rule to each one of them and give a result for each one of them. So again, this is simplifying the life of the business analyst. The business analyst writes a rule for n, I mean, without having to think how many data set are going to be passed in as input. Okay, let's summarize what we've seen. So in a few minutes, you've seen that we created a model from JSON data. We started writing and testing rules, so we can assess our rules even before we deployed in a complex environment. And we have also deployed it to a browser sample to show you a rule running in JavaScript in a browser. We'll see all the targets in a few moments. But the key thing here is everything was done without requiring programming skills. Um, Writing the rule essentially is accessible to business users who are familiar with a spreadsheet model. And now we're going to do a deeper dive, essentially trying to understand the constructs the Corticon Studio provides and the set of tools to help the business user create great features. We call all these no-code or low-code features because they help the business user who is not typically a programmer. So let's jump back to Corticon Studio. Let me close the first example we work on and show you here a more fully developed example. In real life, rules tend to be much more complex than the first example we wrote a few minutes ago. In the field, we have seen rule sheets with thousands of rules. And certainly Corticon can deal with very complex business problems. So to explain these capabilities, I've created a more complete example for our insurance use case. Let's start by looking at the rule flow editor. We said we would come back to the rule flow. Here is an example where we have essentially a decision service that is composed of a set of rule sheets, and each one is connected in sort of a workflow step-by-step process. So if we click on each one of them, we can open a rule sheet. So you see this looks like what we started with, but with more complex rule, where we deal with events-driven, more age, capabilities, and differences were depending on the distance driven. And also, applying the cost or resulting cost. But that's only for the first step. The second step computes the cost based on, again, various criteria, but also the zone in which the car was driven during the day. And we adjust essentially the insurance cost at the end of the day based on the risk of the zone in which it was driven. If we continue, finally, what we do here is adjust the cost of a daily amount we charge based on various criteria. And here I wanted to illustrate a little bit, we have a typical criteria we have for conditions, but we can do also mathematical operations here to increase the cost with a percentage based on applied to the vehicle cost. So all in all, the data is input, the JSON data we get in, and we compute various steps. Each steps can be tested individually, or the entire rule flow can be tested. So again, testing, for example, only the daily insurance would provide a validation that, hey, if I get someone who is between 18 to 25, has only 1 to 29 distance driven, and is more than 2 years driving, I would charge $399. So I can validate all of this one individually, and then I can also write a rule test that validates the entire thing. The final step is an interesting one where we don't do much of any condition assessment, but essentially what we're doing is we are logging a message into the system, and I wanted to use that as an illustration. For auditing purposes, most of the time, business processes need to explain why they reach a conclusion, right? So at the end here, we essentially log what the base price was computed for today, and the number of the distance driven for the age of the driver I mean, for how many years the driver had been driving with us. So this is a great capability because you need to be able to express this auditing or tracing or logging messages in simple ways, and that is simply expressed with this kind of rule statements. We'll see an additional example very soon. Okay, so this covers an introduction to what first of all, the role flow looks like, composition of multiple decision role shared inside a single decision service. But also, now we're going to look into tools we provide to facilitate the business user's life. So we provide many tools. A lot of these tools have to do with logical analysis, rule completeness, or conflict analysis. So I'm not going to go deep into each one of them, but let's look at conflict analysis. This is a good example, good tool to illustrate the power of these capabilities. So let's say that this has been in production for a while, and now we want to change things so that we are gonna do a special offer for driver between 20 to 22 who drive very little during the day. So I have added actually this rule here. So let me turn it on. I can enable this rule. So we can see here, well, actually before I enable, let me disable it again and show you, if I click on conflict here, we have no conflict. So Corticon established that this is like all the rules are independent and not conflicting with each other. So now let's turn this one on. And so essentially this is saying 2022, less than 15 units of distance driven today, and more than 2 years of driving. I'm going to charge $345. So that's my special offer. Fine, what I'm going to do is I'm going to say for this role, I'm going to post an info message on the driver to say something like, hey, special offer for 20 to 22 years old, who drives very little per day. So again, an example of these rule statements that are going to be logged, and we can see here, this one refers to this column, the 12 here. So it's highlighted. But let's come back to our tool here. Let's run a conflict checker. So I run conflicts, and now Corticon automatically detects there is one conflict. So this could be a very complex, and things may not even be in focus. So we have this other tool to just allow us to just see side by side without all the context of the rest to see the rules that are in conflict. So we can see column 2 and 12 are conflicting because, of course, between 18 to 25 and more than 2 years of driving and 1 to 29 units of driving, we charge $399. So how can we resolve this? So obviously one way would be to refine all these rules, but a simple way is to come here and say, hey, I want rule 12 to override no matter what rule 2. So that's my escape mechanism in a sense. So let me run conflict checker again, and we have no more conflict. So we are good. And in just a few seconds, we were able to detect that there was a problem and fix it. So, all right. I'm not going to dive into all these tools, but you can see there are a lot of constructs to develop, maintain, and organize complex projects. And we offer very unique no-code capabilities like raw logic completeness, making sure all my conditions, all the possibilities in all my conditions are covered, right? Do I create logical loop? And as we saw, conflict checker, very useful. And in fact, customers report that conflicts many times come from the requirements document or the requirements discussions. And in typical situation, they go unnoticed because there are just too many conditions, and it's hard to do a logical analysis of all the conditions by hand or even if you write it down, right? So at the end, without Corticon, these conflicts would stay unnoticed for a long time, or possibly not even get noticed ever, never been detected. So that's an example of how we help a business user, and where at the end of the day, you gain productivity and everybody is happy. And now we're going to jump into serverless. Essentially look at how we can deploy these decision services as serverless functions, and let's start with AWS. All right, let's jump into Studio and look at our workflow. So like we did for packaging for the browser, we're going to invoke this dialog, but we're going to say AWS Lambda and generate, finish. And now that all my files have been generated successfully, let me jump into the Lambda AWS console. I'm going to create a function, daily insurance. Let's have it on node 14, that's fine. And create function. Okay, now function is created. Let's upload the zip file. Here we are. We can see we have generated 3 artifacts in this directory, the bundle, the index, which is the entry point to the Lambda function. You can take a look at these files, but everything is packaged into a zip file for you, so we can open it up and upload it directly to Lambda. And when we click save, here we go. We have the Lambda function created in 1 or 2 clicks. So let's test it. We're going to configure a test event. Test with 3 drivers. Copy this here, and let me create this test event so it can be reused. And let's invoke it. And now we can see we have a result. First one is being charged 809, second one 679, and third one 719.99. I mean, at the end of the day, this is like the full computation done in a serverless function. What we also see here is the additional Corticon object literal in the JavaScript in a JSON, which contain overall messages that can be used for auditing or returning to the caller client, justifying each of the computation. Okay, so as you can see, in just less than a minute, we could transform everything the user, the business analyst as model into a package decision service and deploy it to AWS Lambda. As you will notice, here the user, the business user, doesn't have to deal with any of the intricacy of the cloud environment or the browser environment, or AWS Lambda versus other serverless functions. So all in all, you gain a lot of productivity because you don't need to train your users. They don't need to be cognizant of a target platform. They can just write a business logic, make sure they test it well, and then an integrator can take all this and package it and run it at high scale. Now let's look at Google Cloud Platform, abbreviated GCP. Essentially, here, like from the role flow, we can package roles for also Azure, Lambda, or Google Cloud Functions, or serverless platform. So we do it for Google Cloud Platform and finish. And that provides the artifacts, the following artifacts, right? Decision service, an entry point, which again are packaged as a single zip file for conveniently being uploaded to GCP and create a serverless function in just one click. So let's not go through all the details of creating it, but essentially here in my Google Cloud Platform account, I have created one, this time running on Node 10. I have my index and my decision service bundle. The trigger is HTTP, and we're gonna invoke it directly from the outside with Postman. So let's make a quick pass at this. So here I have my payload, and let me send this. And now I get my response. You can see here insurance cost today, 809 and 679, etc. So same result, of course, as running on AWS, but invoked now directly via an HTTP handler. So the point here is to show that essentially whether it's GCP, Azure, or AWS, Corticon is cloud native and cloud agnostic. And that's important. A lot of customers are reporting to us that vendor tie-in is one of the top concerns. So having the flexibility to develop your rules, your business logic in a tool that is cloud agnostic is valuable to be able to move into any other cloud you want to support. But additionally, and that's point number 2, you don't need for your rule development team to learn the cloud or mobile environment or both. They can focus on developing business rules in Corticon and not have to deal with any of the deployment platform artifacts. As point number 3 actually mentioned, right? I mean, it's a role authoring is completely independent of the complexity of any of these platforms. We saw that we provide simple deployment options for various target platforms. The deployment create a single bundle containing all the dependencies. This enables integrators to use the decision services very easily and with any of our current tooling. We have command line interface, so you can integrate into your own CI/CD system to generate these bundles. And additionally, you can use these bundles wherever JavaScript runs. We don't tie in into platform-specific API so that you have as much flexibility as possible. Yeah, and as importantly, Corticon.js provides you with the flexibility of targeting specific cloud or multi-cloud or hybrid cloud, and as well as on-premise. I mean, you can deploy to a known target and run it on-premise if you don't want to be exposed to the cloud. Okay, the last example we're going to look into is a sample we have developed for a customer who wanted to do a solar installation cost, savings, and rebate calculator. So we developed a sample with a cloud workflow solution in AWS using the AWS Step Functions technology. So maybe the first thing, let me run this example once, so you get a feel for what it is. So we have a web interface interfacing to the step functions. I'll talk about that in details later on. But essentially, we're inputting property configuration, some additional info, property value, etc. So a lot of data points about the property on which we want to evaluate a solar installation. And then when we click on the next step, here we illustrate the execution of the step functions, the various workflow actions in the cloud. Okay, and then final step, we get our initial estimate, a rebate calculation, eventual discount, saving you would do on a monthly basis and on 20 years basis. And finally, we get an offer for various loans. And that's part of the workflow, try to entice user to apply for a loan if possible. Okay, so let me run it again. Don't need to change any of the data. And let's focus on the steps here. So as you can see, let me zoom it in. We're executing several steps. What is interesting here is we have what we call a composite application because it's composed of multiple steps, but also it's composed of what we call, obviously, the decision services that are written with Corticon.js, but as well external services. So if we look at, for example, the REST solar price here step, this is not computed by Corticon itself. It's a call made to a REST service to get, hey, what is the current kilowatt hour price for this location? And what are the price of solar panels I can get at this location, etc. So you can see everything prefixed with DS is a decision service from Corticon. So here we have an external REST service call where we get data and we compute more things for input to Corticon decision services. At the end here, we even have a choice. And from that choice, we invoke another REST service to get current loan offer for solar installations. And then we do some business rules on these loan offers and offer the final results to the user. The interesting aspect here is this is a parallel step. So you can see that we take advantage of doing things in parallel to speed up things, where on the left side, we're going to start to compute a rebate for the location and the time of the year, the day, and the year. But at the same time, we're executing the REST solar price call because that's going to take a little bit of time to get a response from a REST service. This one is going to be like a few milliseconds. But at the end of the day, out of this parallel step, we're going to get more JSON data that is going to be used by the decision service. So the key thing here is that Corticon decision services integrate very well inside the AWS workflow system, step function. So actually, let me jump here so you can see this is my AWS step function console where I have defined this composite application. You can see here the same diagram, and it's a little bit smaller, but essentially if we look, some of these steps, for example, here the REST solar price is invoking this Lambda function for making a REST call, but if we go down the saving, we can see here like we're invoking the decision service, another Corticon decision service Lambda function. So all in all, We integrate very well. So the key things here is, if we think about all that, is you have a lot of flexibility how you can design your application. In fact, if we look here, let's open a Solar quote. You see how it's composed of multiple role shades and role flows. So, for example, the loan, the quote, where is the next one? Yeah, rebate and saving. All of these are relatively complex, right? I mean, you have a lot of state conditions, orientation, for example, for the savings. If we look at the rebate, some conditions and computation, and also, rule statements. Again, here, like we defining rules and statement for each of these rules, so that we have auditing of what we have done. But the point is, all of these could be done as a single service, but it would be much more difficult to maintain, would be a very large decision service, and would not be easily integrating with REST services, or you would have to make your REST services calls ahead of time and then pass all the data in at the beginning of the decision service. So rather than doing this, it's better to decompose things in multiple decision services that are easily maintainable. It's truly the microservices architecture, and they can be composed in multiple ways as you see fit. So again, like to conclude on this, we don't force a workflow engine on you. Here, the example was with AWS Step functions, but the same thing can be done in Azure or any other engines that maintain a workflow. The same kind of integration, as a matter of fact, could be done in a similar fashion with machine learning services from any of the cloud vendors. So this illustrates how the composition of decision services offer you a lot of flexibility and agility. In conclusion, Corticon is an enterprise-grade, proven, and stable product. It has been used to develop large-scale apps for over 10 years, and it provides innovative, no-code, low-code capabilities to reduce your cost and your time to market. With Corticon, you future-proof your business logic, as Corticon.js is cloud native, providing you elasticity, scalability, and as well integration with other services like cloud vendors workflow or machine learning offerings. And you future-proof as well your business logic, because Corticon.js is also cloud agnostic. It gives you a lot of flexibility, as you can also deploy some decision service on the client side, mobile or browser apps. This could be used to improve the usability or the scalability and the performance of the app, or simply to work offline when there are no or very poor connections in the environment. Finally, it offers pay-as-you-use licensing options with lots of flexibility. I hope you have found this session useful. We certainly went through a lot of content in a short time, so feel free to contact us if you need help deploying to any of the platforms we have mentioned.